So first, before I begin, I would like to say that I'm very happy to be here. I've put, I don't know if you know SMBC, it's a webcomic, a daily webcomic, quite funny usually. And this is basically how my wife sees me when I talk to her about you. So I wanted to share this excitement with you. And yeah, it's very nice. I was very happy last year when the conference started again after a 10-year gap. And so it's nice that it's now an annual event. And I'm really hoping that next year we will meet again. So what is this all about? Yeah. Why did I try to adapt Listen to a specific Linux distribution? It's because I'm running a public access Unix server called the DAM, and it's not big. The graph you see is the daily active users on the chat we have, so you can see that I'm not alone, but we are not a crowd. So every one of you is welcome. There used to be a 10-euro fees, but it's no more of a anti-spam measure. So if you want to join, I can give you an account for free, of course. But people from the internet that are listening to me now can also join for free. But random people need to pay so that I can have some data to give to the police if they do something bad. Anyway, the goal of porting Listen was to answer one question. This server has a set of a few 10,000s of ports. And I wanted to share those ports fairly and securely with the users of the system. And it's not possible on Linux because you have a dichotomy. Either you are root and you can bind to anything, or you are not root and you can bind to only the unprivileged port, but anybody can. So the fastest win, which is a kind of a silly way to attribute ports. And so I wanted a system where ports were mapped to files, and then we could use file access control in order to share ports. So what is good? You all know what Listen is about, so I'm going to be fast. But as I said, port as files is a good way to use access control on ports. So somebody can bind to a specific set of ports. You can attribute more very easily with just a chmod. It's quite nice. And Listen has a property that because the files are scripts, and those scripts get the data from the standard input and output data to the standard output, they are what I call network-agnostic, which is to say they don't know that they are on the network. So you can use any Unix command line with pipes or whatever, and you can create very easily a network service. So, for example, you kind of all know, but anyway, this is what the echo service on Ninefront looks like. It's just cat, because what you get on the input you give on the output. And on the other side, you will recognize RC HTTPD, which is a script that actually parses and speaks HTTP, which is to me kind of magic, because when I teach that to students, they find it kind of magic because the browser is a black box, and the HTTP seems quite complex to beginners. And when you say, no, you can just parse it and speak HTTP basically with a shell script, it's a very good teaching tool, you know. So I'm happy that such tools exist. And what does it take for Listen to work? It takes two ingredients that Plan9 has, which is per process namespace and unprivileged mounts. Because if you have, if every process is isolated from the rest of the system, then you need to be able to mount stuff in order to populate this namespace to do anything useful. So let's take a look at how it's done in practice. This is the namespace file for the default web server from Ninefront on the right. So you see we bind the web root somewhere, for example. And on the other side, you have the one from the, I guess it's still in Ninefront, but given the name of the machines, I guess it's a remnant from Bell Labs. I don't know, maybe. Does somebody knows where this file comes from?
Yeah, it's old stuff.
But what's interesting, it's like digital archaeology, you know. You see the name of the machines, and you see how the folders were created by binding one folder over the other and so on. So, yes, this is what I show to people who ask me what namespaces are about. So you can basically build your own view of the file system, but you all know that. The problem is when you come to Linux, you can try to make Linux look like Glenda, but it doesn't work because you don't. Yeah. When you have a namespace in Linux, you have Linux namespaces. Why is there us? Why is there multiple namespaces? Because everything is not a file, like at all. So you need to isolate mounting and networking and users and even the sound, I guess, or whatever. You can look in man unshare and you will see all the different kinds of resources you can isolate, and it's not clean at all. And you can do unprivileged mounts. You can use the unshare command to enter a so-called namespace, Linux namespace. And M and R, M is for mount, so you can isolate whatever you mount from the rest of the system. If you mount something in a mount namespace, others will not see it. But in order to be able to do that without being root, you need also to pass a map root user, which give you kind of a fake root, and you will be the root of your own silly kingdom where you are alone. So with both of those, you can kind of manage, kind of. When I started, I was like, okay, this is going to be a 1 week affair. I'm going to work 1 hour a day after the kids are in bed, and I'll be done. And this was like in May last year. And why? Because it's actually quite, the problems I encountered impacted the design. So first question, this is attributed to Rob Pike, but I was not able to find an actual source for the quote. The earliest I could find was Uriel, you all know him, telling us that Pike said that in 1991. But
I think that's a Utah.
That's a?
Utah 2000.
Okay.
It's very old.
Nice. Yeah, so it's even more relevant now. And so what I will do is I will first describe the 3 problems I had. Then I will show you the listen design on Linux. And then I will come back to the problems and explain how these problems impacted the design and why I had to make the choices that I made and that make this design subpar and not as good as in Plan 9, basically. So let's start with the problems. Problem 1, there is no netfs, no /net. So this is the way /net works on Plan 9. You open the TCP clone file, and what you get is not actually an handle on the TCP clone file. It's the handle of some other control file, which you don't know which one yet. You read this file, and you get basically the name, the number of the connection, which you can then use to build the name of the file you actually need to open. But once this file is open, whatever you open, you read and write to this file will be read and written to and from the connection. So this is a clean, very nice design. And it's even cleaner when you look at, so this was, to connect, for example, to example.com, you would do this little dance, which is, of course, abstracted away by some calls that will just do that for you. But when you listen, it's a bit more involved. It begins the same, but then you have to do the little dance again with the new, which the FD for each incoming connection. But what is nice is because you are on Plan 9, for example, listen will be the program here. And when a new connection comes in, you can actually hide all of the rest of the system from the daemon that is the process that is handling the connection. And the process handling the connection does not see the full /net. It only sees this particular directory. So the process that handles the connection is not internet aware, is not even able to make a new connection. So if your process gets compromised by an attacker, then it cannot use your machine to go forward into your network to other machines because it has no internet connection. This is a beautiful design, and I would like to be able to replicate it on Linux. For problem number 2, it's a bit technical, so I have created a visual aid. to help you understand what's actually wrong. So this visual aid will show you what it's like to be inside a Linux mount on user namespace and trying to mount any actually useful file system. So it basically goes like this. It goes like this. So basically what happens is, because you could, if you are an attacker, create your own fake disk, and because unprivileged happen, try to mount this fake data, this crafted data, could go through the kernel and allow you to attack a part of the kernel that is not prepared to handle untrusted user data. So because of that, the kernel developers said, okay, unprivileged mounts are good, but only for trivial file systems. So TMPFS, for example, but any useful data file system like X or whatever, FAT even, is forbidden. What you can mount is Fuse. It's basically the only useful file system that you can mount. I do believe that VNFFS, the 9p implementation in kernel, should have made the cut, but from what I gathered from my peering at the Linux kernel mailing list, nobody actually got around to do it, and so it stays undone for now. So you cannot use the VNFFS, which is quite good and that I want to use because its performance is good and it accepts all versions of the protocol, but you cannot within a user namespace. So, and the third problem is that privilege in Linux is inherited and inherited only. So if you are inside the namespace, you cannot get privilege by any means. So tricks that you may use outside of a namespace, like for example, setuid. I don't know you mount a 9p system on Linux, but I use 9mount, which is a setuid utility that will call mount for me, but as root, and it's quite secure and it's well made. But from a user namespace, it's not going to work. Same for capabilities. So for example, if I want to bind to a port, I can get a capability that will let me do that without being root. But from inside the namespace, it's not going to work. And this is not documented anywhere. I had to email the kernel developers, and they told me, yeah, what you want to do is nice, but it's not possible as of now. So this is a design that I ended up with. Basically, you have your listen process that will share some file with a container. I will say container to avoid using namespace because namespace is a Plan 9 concept. So inside your container, you mount some. These paths are specific to Guix. I will explain them later. But basically, you have your for directory where every service exists, and this the runtime directory for the service is mounted as just /run. So if you don't have to know which service you are, for example, you can just go to /run and it will be mounted in the right place. And same for log or whatever. And what basically happens is this script starts, and as soon as it starts, and if it works correctly, it will create this socket. And as soon as listen sees that this socket is created, it will use socket to listen from on the network and plug all the data to the socket. So this is my way of, compensating the lack of a /net. I use 2 instances of socket. So now that you've seen the design a bit, let's see how it's why it's that way. So for example, in Plan 9, we don't have socket. What is socket? Socket is a small utility that will let you plug any 2 types of input-output. So if you want to talk to a FIFO, but your process will only listen on a port, you can use socket in between to take data from the FIFO to the port and back to the FIFO. Same for a Unix domain socket and a remote socket, for example. So you can pipe any kind of standard input, standard output. Anything you want, you can pipe it with socket. It's very nice. Yeah, so listen.c. These 3 lines that I have highlighted, I can maybe be a bit bigger. this is on plan 9. What you do is you remember the data when we did the little dance to get there. We get a data file handle. Okay, this is the internet connection. This is a file handle, but when you read and write to this file handle, you will get data to and from the internet. And so there is such. This is such a file handle. So what they do is this file they bind it to devcons. So if the child process, the server process, is trying to access the standard input and standard output via opening devcons, what it's going to get is data from the internet. But the file process is not even going to realize that. And same for the already opened standard input and standard output. They get what they get instead is a duplication of the file handle. So with 3 lines, plan 9 is able to not need socket. But because I don't have a /net, I'm not able to have a file handle that represents the internet connection, so I cannot duplicate it to the standards and standard streams. So what I had to do instead is use socket twice, once to get data from the internet to a socket, and once again from the socket to the standard input, standard output. So this is ugly, but I have no choice. Same, the particular directory under /net for the connection is given as a third argument to the services. Not many services use that, but if you actually print your arguments, you will see that the third argument given to the service is the particular directory where the connection happens. So you can do stuff with the connection. Because there is no /net, there is no such thing on Linux as well. Let me just check. Yeah. Also, because some plan 9 services rely on /net being there, I cannot directly port plan 9 services to my system on Linux because they will just fail because /net doesn't exist. So there is some portability work to do if I want to enjoy all the services that people are deploying on Linux. Okay, in my paper, if you read the actual paper, I've made a bold claim. I've said that without my fuse wrapper, which is called F29P, there was no way to mount 9p2000.l server on inside the Linux container. This is actually true, but it's a bit of an overclaim, and I apologize for that, because I've systematically now tested every Linux 9p server against every Linux 9p client to see if they were compatible between one another. And this is what I found. So this is with root. So basically, almost everybody can mount a U9FS, and nobody can mount P9UFS. But P9UFS is the nicest of all. It's written in Go, it's quite fast, and it's actually quite clean. Sorry? Yeah.
That's the one from Google?
Yeah, the one you told me to use.
I use it all the time.
Yeah, it's very nice.
So why didn't it work for you?
It's unable to negotiate a version with older software. So if you don't tell it you're speaking exactly the good version, just at the version negotiation, it's going to fail. I think this is easily fixable, but as of now, it doesn't work. Yeah, so most of them work, but when you get into a user namespace, remember, if you try to use an in-kernel implementation, you won't be able to because it's forbidden. So you're left with those one, and U9FS needs to run as root because it does some authentication and it's going to want to switch users. So you can fake root by running the server process in a namespace as well, but it's a bit more involved, but it's possible. So that's why you put them in yellow and not in green. So you're left with that, and the problem is 9p fuse is not speaking 9p2000.l, but just 9p2000. So if you have some calls that you want to make, you may run into some incompatibilities. Some system calls may be silently ignored by 9p fuse or whatever. And the same goes from 9pfs because it's not going to use the best version for, I think it's, yeah, diode, for example, can speak 2000.l, but it's not going to do that with 9p fuse, for example. It's going to downgrade the protocol to 9p2000. So if you rely on .l features, it just doesn't work. So the best couple stays P9 UFS and F29P. And we wouldn't need this part if this was allowed inside a user namespace. We would just use all the in-kernel implementation, which is the best of all. Also, because inside the kernel you cannot get capabilities or set UID, I could not put the listening process, listen, inside the container. Let me go back to the design. This should be also in a container because it's connected to the internet, so an attacker can maybe get a hold of this process. And if they do, they have full access, not full access to the system, they are still constrained as the listen user, which is a nobody-like user, but still they can listen on any port and they can mess with existing servers. If it was in a container, the damage they could do would be much less. So I would have liked to run this process in a container, but I cannot, because if I did, I wouldn't be able to bind to ports, so I wouldn't be able to listen, which was the whole goal. So, and what is infuriating, when I looked at the source, is that the kernel keeps track of in which namespace you are capable, because you can give yourself capabilities inside the namespace, and these capabilities will be true in your namespace, but false outside. So if you have a setcap binary outside of your namespace, and you try to use it inside, the kernel knows that it's actually a capable binary, but just will not let you use that. So I don't know why. I think it's because the design was bolted over afterwards, but yeah, it's not good. Let's see how it goes from the point of view of the user, basically. So this is echo service, and the user doesn't have to worry about any complicated stuff. Yeah, on this. So if I list my TCP7 script, it's just a link to cat. So this is easy. It's even easier than in main front. Let's look now at the finger server. I've created a finger server, but the finger server is only useful if you can access data from the hard drive. Otherwise, you don't have anything to answer. So what I did is I created a container which ran a 9P server. And this container speaks 9P on a socket. This socket appears in the namespace of the listening service, which will mount it, and the actual script can go and see that the data. And this is done not like in Plan9 with a namespace file, for a reason that I'm not entirely clear with. A namespace file in Plan9 looks like a script, but is not a script. It's something that you give to the calls newNS and addNS, I guess, but it's not a script. I don't have any of those system calls, so I had to create a script. Yeah, this is what they look like. So it's a script. What they do is they just mount. This is like a bind. They mount the finger folder over to a survey finger, and then they just exec whatever command is given to them. And this is what you saw on the. This is this link. So the namespace script is run before the service, and then the service script gets the data and in a namespace that is built for it. And then I'm very happy, Ori, that you showed your TCP 9418 script, because you showed that it's possible to speak Git on the standard streams. But I'm a bit lazy and I didn't want to do that. So what I did is I abused the namespace script, and in order to leverage a server that would not talk to the standard stream. So if you want to serve the Git protocol and you only have the Git executable, you cannot do that on the standard streams. So if you just run git daemon, what you get is a server that listens on port 9418. So my namespace script for this one, it mounts the directory where Git repository lives, and then it creates a fake network interface, and it runs the Git daemon, but it does not exec the command that is given to it by listen. Instead, it execs sockets, and what socket will do is create this socket And so we can redirect, instead of redirecting the data from the internet to the input-output of Git daemon, which won't speak any coherent protocol, what we do is we redirect it to the port instead. And so by abusing the namespace script, we are able to use listen even if we don't have a piece of software that uses the standard streams. So this is a way to stay compatible with the whole slew of servers on Unix that does not use the standard streams. So this is a bit of a hack, but it works. And that way you can have any web interface that you want. You are talking about web interface to Git. I can run like Git.r or whatever inside the namespace script and then redirect data from the socket to the port, and then it's going to work. If you want to try, you can netcat to port 109, and let me show you what's behind port 109. Can you guess what will be behind port 109? It's a link to bash. I am confident in my containerization, so you can run bash commands. Yeah. So have at it. Please do not do a fork bomb because I do not protect myself against resource exhaustion. But if you can try to access files you should not be able to access, or if you manage somehow to exit the container, I would be very happy to know about it. And I have no money to offer you as a reward, but you have my thanks. So you can play with it. It's live now, and if you want to try, you can. I'll probably stop it after today, but you can try. Yeah, and the software you have available, for example, if you do, you see you're there, but you don't have like a lot of software because you are on the default namespace with the default profile. The listen server needs Python, for example. In order to give Python to the listen server, I had to create a profile. The profile is just a directory in which Guix will put links to the store where where all the software is. So, for example, if I do that, listen TCP 77. Yeah, of course. So, for example, you can see that this profile is a directory with like a bin, a share, whatever, and anything that the software needs is actually links to the store, and the store is a read-only place where Guix only can put executable files. So this is another way of securing the stuff. The server only gets exactly the piece of software they need and nothing else. So this is for my finger server, which is written in Python. But if you try port 109, you will end up with a default profile, which is this one, I guess. And yeah, I can show you what's inside. You get Guix, of course, you get bash, you get the core utils, socat, and you get the utils to get a fake network interface. But that's basically it. So the opportunity to get the specific binary you need in order to do privilege escalation, for example, are very slim. It's not impossible, but still, it's less open than a full-blown Ubuntu system, for example. Yeah, so let me just talk very briefly about Guix. I think I'm running out of time, but I'm not sure. So Guix is a Linux distribution. Basically, if I had to do the history of Guix very quickly, it's some guy in 2012 decided, okay, it sure would be nice if my scientific processes of data analysis were reproducible, so I need reproducible packages. And in the quest for reproducible packages, he understood that he needed to do a whole OS because to actually build bit by bit reproducible packages, you need to know what your dependencies are, what is the environment in which you are building them, and you need to stabilize all of that, and in the end you are building a full-blown OS. So what is good about Guix? There is no systemd. This is very good, very you can understand what's going on. You have atomic updates, either it updates or it doesn't, and if the update is not good for you, you can roll back for free, because as I showed you, everything is a bunch of links. So you can edit the store, but the store is a content addressed store. So it doesn't erase your previous installation. And if you want to go back, you just have to change a bunch of links, and you can go back very easily. And everything is declarative. And for example, you've all heard about the XDead attack recently. You know what I'm talking about, right? Some guy took 2 years to become a maintainer on some compression software, and he introduced some very subtle test data, and this test data was used to create a script that was used to put some bad code into SSHD, which is beautiful when you think about it. So this is not impossible to carry out with Guix, but it's much harder, and because you have all the dependencies that are listed, and it's very easy to audit them and to freeze them once and for all. So I cannot talk about that because I have only 20 minutes, but if you want to know more, I can talk for hours about this, and it's for the supply chain attack, it's very good. It's very nice. This is what my configuration looks like to install Listen on a Guix OS. So you see it looks like, I actually need to put it bigger maybe. It looks like an imperative, like a Docker file or some imperative language. So you say, yeah, I want those packages, I want to create this group, I want to create a nobody-like user called Listen. I need to make those directories with those mods and so on. But in fact, it's not an imperative language at all. It's in a dialect of Lisp called scheme. And you see this little operator there. It's a bit of syntax that will take the return value of this function, because this is a function call, and put that as the first argument of the next function. So what you see here are actually nested function calls and not imperative instructions. And this is very nice because you have a full-blown programming language. And for example, something I did is, okay, I have Listen, but I need to share ports between users. So when a new user comes in, I need to allocate a range of ports to this user. And this is some bootkeeping. If I do that in a linear manner, when somebody leaves the server, then I have a hole. I need to defrag my ports on it. So what I did instead is I wrote a bit of scheme, and I just take the hash of the username. This gives me an int, and I use this int as the start of the range. The collision risk is minimal, and a user can come and go, and this is an automatic attribution chain that actually works. And I can do that because the language, the configuration language, is a full-blown programming language. It's not like in Ansible, like a YAML or whatever. It's a real programming language. So this is, you get both. You get like, let me get back to it. You get easy intuitive when what you want to do is easy, but if what you want to do is complicated, you can also do it. So you get both. Anyway, time to wrap up. What am I going to do in the next few months? I would like to edit P9 UFS so that it can negotiate the version better and maybe work with the existing software. Because I think once the version negotiation is done, it can the needed the modifications that are needed are not very big. If anybody here has experiences proposing a patch to the Linux kernel, I would very much like the v9fs to be marked as safe, so that we can enjoy it inside containers, because so far it's not possible. So if you can, please talk to me, because I have no experience in that domain. If you want an account on the DAM, I will be very happy to welcome you. And then if you have creative uses for Listen, you will be able to use it and create scripts that will listen on the internet. And also, /net is just so good. So I would like to first fake it, like create a fuse file system that behaves like /net, and so that we can use it and begin to see if it's actually useful on Linux. And if it is, armed with that experience, maybe we can prepare a patch for the Linux kernel and someday have an actual /net. I mean, Linux stole the /pros from Plan9, so maybe we can steal the /net as well. That would be nice.
Yeah, I think there was a project called Guix, trying to do this kind of stuff. Like try to emulate Plan9 environment on Linux kernel. I'm not sure how far they got before they abandoned it, but yeah, I might try to explore. Maybe it's done.
Okay, yeah, I'll look into it. I've heard the name already, but I didn't know. I don't know where they went. And last, I would like to thank you all for being so attentive when I talked, and also thanks to the reviewer of the paper, because my code was shittier before, and thanks to the review, I, for example, extracted all the namespace stuff out of the script. So, for example, the the TCP7 service, before the reviews, included the socat invocation, which was not intuitive at all. And thanks to the review, I was able to understand that I should extract it, and I created the namespace scripts and so on. So the reviews were actually helpful, and I've submitted a lot of papers to a lot of conferences in my life, and I can tell you that actually helpful reviews are very rare, so I'm very happy that I got actually helpful reviews, and thank you to the reviewers. And thank you also to the participants of last conference. So Ron is here, and Skip also, I think you are listening. And during the workshop, you provided me with very interesting information that I used in my research afterwards. So thank you all. I will yield the floor then. Okay.
No more questions? There is one.
Oh, sorry. Yeah.
So, to mark file system as safe,
Yeah.
when they want to disallow having device specials and some of the other things, I guess that's maybe out of scope for what you're talking about, but this whole idea of marking v9fs as safe. If it's .l and it's allowing a lot of things, it would, I think, make it inherently unsafe. Whereas if you're running IP2000 period, nothing else, then I would think it'd be safe.
From my understanding, the unsafe part was really the handling of user-crafted data inside of the kernel. Even 9p2000.l is just passing data around between the server and the client. I don't think that.
What is time of check, time of use concerns? Is that what they're talking about, or is it unchecked data, or
I don't know exactly what it does with the data, but there is some processing inside the kernel that is not guarded against, for example, I don't know, a buffer overflow or lying about the size of the buffer or whatever.
Yeah. Okay.
And I don't think that v9fs is actually doing much with the data, instead of just correctly giving it out to the actual processor, which is outside. So
I've had many interactions with the current maintainers for a while, so if you want to write it up, we can go to them and talk to them about it.
That would be awesome, yeah. Moody?
My guess would be that it's not safe because nobody's putting the effort to say this is safe.
That's what I understood from the mailing list discussion.
I think that's probably true.
There's no fundamental reason, just nobody's done the work.
Yeah, and it's a whitelist. I mean, it's.
I mean, the maintainers are still there and they're still enthusiastic about it.
I've seen them remove other things because of that. So I was thinking.
Yeah, no, I have had interactions with them in the last year, because actually they introduced a bug that was pretty bad, but they were super helpful about fixing the bug. Although the sad result is that because the bug was there for 18 months, all the 9p servers on Linux have to be willing to walk an open FID. So, oh well. But yeah, nothing you can do because it's the majority of uses of 9p, let's face it, are Linux.